Let's now have a look at determinants. A determinant is a number associated with a square matrix. So as mentioned, a square matrix has a number known as a determinant associated with it. And for determinants, we use the vertical bracket notation. So if matrix A is, for example, a matrix 2, 3, minus 5, 7, then we say that the determinant of A is this determinant here. Square brackets surrounding this structure here, 2, 3, minus 5, 7. Now it can only be a square matrix that has a determinant associated with it. Now let's start with the smallest square matrix, a 1 by 1 matrix. If you have a 1 by 1 matrix, then the determinant associated with this matrix is simply the value of the single element in the matrix. So that's where we start, the single element in the matrix. Next, a 2 by 2 determinant. The most general 2 by 2 determinant, A, B, C, D. And the value of this determinant is AD minus BC. Multiply the two elements along the main diagonal and then subtract the product of the remaining two elements. And let's see some examples of determinants, 1 by 1 or 2 by 2 determinants. So the first one, the determinant 6. A 1 by 1 determinant, this is simply equal to 6. The determinant 5, 6, minus 7, 3 will be 5 times 3, multiply the element on the main diagonal, minus, and then subtract off the product of the remaining two. That is 6 times minus 7. So it gives us 15 minus 42. This determinant comes to 57. One more. 4 minus 6 minus 10, 15. We do the same thing. 4 times 15 minus 6 times minus 10. 60 minus 60. This determinant is 0. We will see later that a determinant of 0 has significance. The first two determinants were positive. A determinant can also be negative. If we want to work out a determinant of a larger matrix, 3 by 3, 4 by 4, or larger, we would expand along any row or down any column, multiplying the entry that we come across by the n-1 by n-1 determinant, not including that row or column, and also multiplied by the sign that we see in the table here, starting with a plus in the top left, and then alternately negative and positive going down or going across. Okay, what do we mean by this? We work along any row or column and we multiply the entry by the n-1 by n-1 determinant, not involving that row or column. So for a 3 by 3 determinant, we can work our way along any of the rows or down any of the columns, at each stage multiplying the entry by the 2 by 2 determinant, not involving that row or column, and also by the sign in the table here. So let's say we want to expand our way along the top row. Often we'll use the top row, but sometimes we need to look out for ways in which we can make use of other rows, or indeed any of the columns. So we start off with our 2, and then we multiply by the 2 by 2 determinant, not involving the same row or the same column as the 2. So it's this 7 minus 5, 4, 7 determinant. And we also multiply by plus 1. And then we come to the 4. We multiply the 4 by the negative from here, and also by the 2 by 2, not involving this top row or this middle column. So we have 3 minus 5 minus 5, 7. Then also plus from here, minus 1, and the 2 by 2, not involving this row or this column. So 3, 7, minus 5, 4. So now we can carry out the 2 by 2 determinants. 49 minus minus 20, 21 minus 25, 12 minus minus 35. Do a bit more arithmetic. This determinant here comes out to 107. But we could do the same calculation using any of the rows, any of the columns. For example, let's expand down the middle column. Now going down the middle column, we see the signs here are minus, plus, minus. So we'll have minus 4 times this 2 by 2, not involving the top row or the middle column, plus 7, and now the 2 by 2, not involving the middle row or the middle column, as in it's the corners, minus 4 times, cover up this row, cover up this column, 2 minus 1, 3, 5. And again, we calculate the 2 by 2 determinants. This one is still 21 minus 25. This one, 14 minus 5. And then we have minus 10 plus 3. That's minus 7. Do the arithmetic, and of course, it's the same answer that comes out. So indeed, you can go along any row or down any column, you'll get the same result. And sometimes it might be the presence of zeros that makes you decide to do it a particular way. Whichever way you do it, remember the signs in the table here. So let's look at 2 determinants as mentioned here. Let's decide we're going to expand along the top row. Now before doing that, let's just note the signs that we'll use. We always start plus in the top left corner, then alternately minuses and plus going along each row or down each column. So we will have, going along the top row, plus 2 times the 2 by 2 determinant, not involving this row or this column. That is 5, 8, 4, 9. And then minus, we have our 7. And then the 2 by 2, not involving the top row or the middle column, we get 1, 8, minus 2, 9. And now plus, the sign here, minus 4, and the 2 by 2 that we have here doesn't involve the top row or the right column. It's 1, 5, minus 2, 4. So we have 2 times 45 minus 32 minus 7 times 9 minus 16 minus 4 times 4 minus 10. So 2 times 13 minus 7 times 25 minus 4 times 14. So we get here 26 minus 175 minus 56, or minus 175 minus 30, it comes to minus 205. We did it using the top row, but we could have used any of the rows, or indeed any of the columns. Now the second one here, we could again use any row or any column, taking into account the pattern of plus and minus signs. But let's expand down the right column. We choose the right column, noting there are 2 zeros in it. So we're going down the right column. We will have 2 plus 2 times the 2 by 2 not involving the top row or the right column. That is minus 1, 4, 2, 6. Minus 0 times another determinant. It doesn't really matter what's in this determinant because it's going to be multiplied by 0. Similarly, plus 0 times another 2 by 2 determinant. The point is, both of those terms are 0. So we have 2 times minus 6 minus 8 minus 0 plus 0. So 2 times minus 14, it comes to minus 28. We can indeed find a 4 by 4 determinant. Again, we use the same table here. For a 4 by 4 determinant, we put an extra row and column onto the 3 by 3 table here. So we have it in terms of a 4 by 4 grid of pluses and minuses. Let's expand in this case along the second row. So it's the signs along here, minus 5 times the 3 by 3 not involving this row or this column. So it's 6 minus 1, 2, 3, 3, 2, minus 2, 1, 3. And then we have plus 4 times the 3 by 3 not involving this row or this column. So 4 minus 1, 2, 0, 3, 2, 0, 1, 3, and then 2 others which will be multiplied by 0. We have 2 3 by 3 determinants, although it could have been 4 of them. We need to express each of those in terms of 2 by 2 determinants. The first one here, we can expand along the top row. We get it in terms of 2 by 2 determinants. This one here, let's go down the first column. So we have 4 times this 2 by 2 and other terms of 0. Well, now it's just come down to some arithmetic once we evaluate our 2 by 2 determinants, and the whole thing comes to minus 253.